Blueprints is how we let your team take any SOC workflow you're running manually today and turn it into a repeatable, AI-driven automation. You define the workflow once in plain English in a visual builder, and every analyst on your team runs it the same way, every time. Today I'm showing you data onboarding for Snowflake. This is the workflow a security data engineer runs when there's a new vendor feed in Snowflake that needs to be normalized into a clean schema and stitched into your detection content. We've heard from customers that this is one of the most time-consuming, contractor-heavy efforts in security data engineering. One large customer had 9 consultants working for several months, costing millions, just onboarding feeds. This blueprint takes that from months to minutes. I'll walk you through how the blueprint is built, show you what the raw data we're working with actually looks like, then walk through a real run end-to-end. What you're looking at is a structured, gated workflow. 2 intro blocks up top, background and gold schema, and 7 gated steps in the middle, numbered 0 through 6. Each step has explicit inputs, actions, validation, and a user confirmation checkpoint. Nothing proceeds until the prior step is signed off. Background sets the scope. The deliverable is the Snowflake SQL that transforms a raw feed into the gold schema. 2 deployment modes baked in: gold pipeline if the role can write to gold, or data retrieval as a reusable macro if not. Gold schema is the contract: 7 domains: cloud, auth, email, endpoint network, web, DNS, each with required and optional fields. This is what the blueprint normalizes everything into. And then the 7 steps themselves: workspace discovery, source sampling, timestamp handling, field mapping, performance testing, audit documentation, and deployment. The key thing to notice: every step is written in plain English. Your senior engineer can read this, fork it, tighten it for your environment. That's the version your team runs going forward. Before we run the blueprint, let me show you what this raw data actually looks like today. This is the kind of feed sitting in your bronze tier, waiting to be onboarded. This is a CrowdStrike feed in raw form, 5 columns total, but look where the data is. The entire row is dominated by this one column, raw data, with a giant JSON blob inside. Every event packed into a single variant field with 60+ nested keys, command lines, file paths, hashes, usernames, timestamps, environment variables, all jammed in there as raw text. This is what an analyst trying to write detections against this feed is starting with. None of these nested keys are queryable as structured fields. Your detection content can't reference any of them. It's just one big string. Now, this is what every new feed looks like when it first lands in bronze. Onboarding means taking this and turning it into structured, schema-aligned columns. Manually, that's where contractors spend weeks. Let's see what the blueprint does with it. This is a session I ran earlier today against that exact feed. I'm not going to re-execute it. I want you to actually see the outputs without waiting on the query runs. I told the blueprint I wanted to onboard data, but didn't specify a source. So step 0 ran the workspace inventory, every existing macro, every bronze and silver table available. It computed the delta and produced a ranked list of onboarding candidates by volume, freshness, and domain fit. Top candidate is the bronze CrowdStrike feed you just saw. Over 250 million rows, classified as endpoint domain. That's the one I picked. Step 1, first checked whether a macro already existed for this table. It found 4 existing macros pointing at the silver tier derivatives, but no macro on the raw bronze table. So we're building the gold pipeline for the part that hasn't been done yet. It pulled the sample, confirmed the same 5-column shape you just saw in advanced search, and proposed endpoint as the gold domain because the sample is dominated by process execution events. Confirmed. Step 2 is where the blueprint resolves the event timestamp. And it caught 2 things here that a junior engineer might miss. First, there's a column right there in the table schema labeled as a timestamp. Looks like a great candidate for event time. The blueprint refused to use it. It's the ingestion time, not the event time. Using it would shift every detection's timing by however long ingestion takes. The blueprint went deeper into the JSON variant to find the actual event timestamp. Second, the timestamp inside the JSON is in milliseconds. The gold schema expects seconds. The blueprint caught the scale difference and generated the correct conversion. That's the kind of bug that ships silently and corrupts months of detection logic before anyone notices. Both decisions validated against real rows. Real timestamps, real conversion, real check. Step 3 is where the select gets built, the SQL that actually transforms that JSON blob into structured columns. 11 of 12 required endpoint fields populated from source data. One field, parent process path, auto-nulled because CrowdStrike doesn't carry it. The blueprint flagged it with a to-do comment instead of guessing. Look at what's happening here. The blueprint is reaching into the JSON variant and pulling out individual fields, the command line, the image path, the username, the parent process, and projecting each one into its own clean column. 60-plus JSON fields become structured columns. 3 judgment calls worth noting. For the host field, it prefers the normalized convenience column, but falls back to the JSON if the convenience column is empty. For the process hash, it tries the strongest hash first, falls back to the next strongest, then the weakest, because CrowdStrike drops the stronger hashes on certain event types. And for the process name, it derives the file name from the full image path. Every one of those is something a senior engineer would think to do. Step 4 runs a performance test. 100,000 rows on a small warehouse, real Snowflake query, real metrics from query history, just over 2 seconds elapsed, 43 megabytes scanned, comfortably within budget for a 1-minute scheduled task. And the blueprint walked a pitfall checklist, caught 2 reliability concerns on its own. One pattern that should be optimized at scale, and a strict conversion that could fail a scheduled task on a malformed row, both flagged with proposed fixes. Verdict: ready with caveats. Both items get documented in the audit report. Step 5 produces the audit report, the durable artifact that lives alongside the code for years. 8 sections covering feed overview, domain selection, timestamp handling, mapping decisions, performance profile, the select verbatim, open items, and deployment status. Right here in section 3, the 2 precision calls from step 2 are permanently captured. Anyone reading this 6 months from now knows exactly why the macro is shaped the way it is. And section 7 documents the 2 hardening items step 4 caught with proposed fixes, not blockers, but on the books. Step 6 is deployment. The blueprint paused at a confirmation gate first. Macro creation is a platform change. The blueprint never deploys without explicit approval. Once confirmed, the macro was created in Anvilogic with a unique ID, deployed to Snowflake. Status moved from queued to deployed. Cron schedule set every minute. Role-based permissions configured automatically. Real artifact, real deployment, real schedule. And here's the macro the blueprint just created, sitting in your library alongside everything else your team has built. Vendor CrowdStrike, type data retrieval, deployed. This is the macro detail page, full metadata, plain English description, labeled with the relevant tags, and the deployed select body, exactly what we just watched the blueprint generate. Now, back to the data. Same advanced search, same source table, but this time we're running the select the blueprint generated. And here's the after. Look at the left panel. Every one of those fields is now a structured column the analyst can query, filter, and join on. Event time, user, event platform, signature, process, process path, process name, process hash, parent process, source process ID, target process ID, all extracted from inside that JSON blob and projected as their own columns, ready for detection content. Same source data we looked at 5 minutes ago, same 5 rows. The blueprint built the bridge between them, and the bridge is a deployed, scheduled macro running on Snowflake every minute, normalizing every new row that lands. To recap, we saw the raw data we were starting with. Workspace discovery surfaced ranked candidates. Macro reconciliation prevented duplicate work. The blueprint refused a misleading source field and caught a scale conversion bug. 11 of 12 required fields mapped. Performance test passed with real measured numbers. A full audit report captured every decision permanently. A real macro got deployed, and the raw JSON blob became clean, normalized columns ready for detection content. Every step of that workflow is defined in plain English on the canvas. Your team can edit it, version it, swap connectors, adjust the gates. It's your playbook, executed consistently, every time. If onboarding new data sources is eating weeks of engineering time on your team, we'd love to show you this, running against your own data. Book a demo with our team, link below this video, and we'll walk through how this blueprint and others like it can fit into your environment, from months to minutes, on the feeds that actually matter to you.